we will need to be able to evaluate a situation when we have a modulus function existing within a definite integral. And to do this, we need to be seeing this as an area question on top of it being just a pure definite integral question. And the first thing that we should do is to try to draw a graph for the expression that is within the integral. So I'll let this be y. If I were to draw this graph, it is going to be something like this. The x-axis, the y-axis, the graph will be like this. Here, you go back up. And this will be the graph of y is equal to modulus of x squared minus 4x plus 3. 0 will be here, 1 will be here, 3 will be here. And if I were to see this as one that represents what that is on this graph, it is going to be the area. Area from 0 all the way until 2. And this region here will represent the area, which is actually what this is evaluating. So what we will need to do next is, because we cannot be evaluating this ourselves when we have a modulus function, so what we will do is we will try to remove the modulus function, replacing it with a plus minus. Then we will draw two more graphs. One graph will be y is equal to x squared minus 4x plus 3. The other graph will be y is minus x squared minus 4x plus 3. For this graph that is here, we will be getting something like this. The y-axis, the x-axis, the graph will be like this, going back up. Here will be 0, here will be 1, here will be 3. And if you to compare this graph to this graph, actually this portion is exactly the same as this portion, which means that this area can also be calculated based on this area here. And for this, it is going to be a graph that is something like this. The x-axis, the y-axis, the graph will be something like this. Here will be 1, here will be 3. And if I were to look from 1 to 2, this region here will be simulating this region. So now we have our answer. Another way for us to be re-expressing this, and this time without the modulus function, will be for this region to be simulated by this. So it's going to be integrating from 0 to 1 of x squared minus 4x plus 3 dx plus this region, which is going to be simulated by this. So the other region is going to be integration from 1 to 2 of minus x squared minus 4x plus 3 dx. And now we can evaluate our integral manually, because now we have integrals that has no modulus function. So let's do that. For integration of this, it is going to be x to the power of 3 over 3 minus 4x squared over 2 plus 3x, 0 to 1. Plus this is going to be minus x to the power of 3 over 3 plus 4x squared over 2, then minus 3x from 1 to 2. If I were to be evaluating this, this is going to be equal to 4 over 3. This portion here will be a 2 over 3. So this is going to be equal to 2.